So now we're at our final step then, or final step in the verification, where we want to test, is the actual data plane working? And just like we did in the core, there's two ways that we need to do this. We need to make sure that the star, G trees can be built to the rendezvous point, because the rendezvous point is the root of the shared tree, or the star, G. Then we want to make sure that the S, G can register to the RP. So when a new sender comes onto the network, are we actually able to tell the rendezvous point that I know about someone sending? Then the final step, once the rendezvous point knows about both the sender and the receiver, can we actually build the shortest path tree from the receiver all the way back to the sender? And this is going to be our S, G tree from the sender all the way to the receiver. That one is our final verification. This would be like our ICMP pings going all the way from the sender to the receiver and then getting the echo replies back. So then let's verify the first of these. Can we build the shared tree to the rendezvous point? Testing this is very straightforward. The only thing that we need to do is to join a multicast group, which is going to send an IGMP report message that's going to change into a PIM join, which should go up the reverse path tree towards the rendezvous point. Now, the places that I want to do this specifically here in this topology are from the other customer sites, because I'm going to assume that if router 7 has a join come in from one of its LAN segments, there should be no problem with the PIM join message going to router 1, because these devices are directly PIM adjacent. There's going to be no issues there. What I want to really test is if a report comes in from the LAN segment of router 8 or from router 10, can these joins then go over to the provider edge and get encapsulated inside the GRE tunnels and then go all the way to the final rendezvous point? So I want to see if I go to 8 and 10 and do IGMP joins, is router 1 going to know about this? So right now on router 1, let's look at the global multicast routing table. We'll show IP mroute. At this point, there's no senders, there's no receivers, so essentially the table is blank. There's 224.0.1.40. This is for auto RP, but we're not running auto RP, so we can ignore this. So next, let's go to router 8, and let's say on that link that we're using to reach XR2, we'll say IP IGMP join 228.888. So any random multicast address, because we're servicing the full range, 224.0.0.0/4. Now, if the MDT tunnels are working, we should be able to look at the rendezvous point and now show IP mroute for 228.888 and see the star, G, which we do. The outgoing interface is fast Ethernet 0/0, which should ideally point us towards the provider edge. So this is the outgoing interface list towards the provider edge. Router 2 is going to say the outgoing interface is the MDT tunnel. XR1 should say the outgoing interface is the POS 0600, and XR2 is going to say it's that gig link. So we're tracing from the rendezvous point, which is the root of the shared tree, down towards the receiver. So now on router 2, if we were to say show IP mroute for VRF-A, do we know about 228.888, which we do? The outgoing interface is the MDT tunnel. If we were to go to XR1 and look at the same thing, this is not going to be the show IP mroute, but instead this is going to be the show PIM VRF-A topology. So we do know about the 228.888. It says the incoming interface is the MDT tunnel to router 2. The outgoing interface is the packet over sonnet link down to XR2. XR2, likewise, if we show PIM topology, where here, notice this one is in the global table, where in XR1, that was in the VRF table. So I said show PIM VRF-A topology. Then on the customer edge, I said just show PIM topology. But this is then pointing down to where the join came from. So this is now telling us that when the IGMP report comes from the actual receiver the receiver is able to change this into a PIM join that is a star comma G join because it's joining the shared tree, and this got all the way back to the rendezvous point. So this means that the site that's being serviced by XR1, that's working fine. Let's do the same thing on router 10 then. If we were to go to router 10, let's say we go to its interface fast Ethernet 00, say IP HMP join 224.10.10.10. And before we do this, if on router 1 we show IP mroute 224.10.10.10, right now we do not know about the group because there's no senders or receivers. Once we join it, router 1 should now know about it, which it does. Router 2 is going to say that the outgoing interface for this is going to be the MDT tunnel towards router 5. So the multi-point tunnel. Router 5 should say the incoming interface is the MDT tunnel from router 2. We show IP mroute for VRFA. We should have 224.10.10.10, which we do. It says incoming interface is tunnel 1 with the RPF neighbor of router 2, and then it's forwarding down towards the customer. On router 9, who is the CE, this is going to be just in the normal global table. Show IP mroute. Okay, so now we know that the shared tree joining is working, that we can get the S, G's up to the rendezvous point inside of the customer network. Second step then would be to test, can we get the registrations to work? The registrations are going to be checking our ability to do the S, G pair. So this first one's working here. Okay, next one we want to know, can we register with the rendezvous point and tell them about the senders? In order to do this, I mentioned this a little bit before, the device that is actually originating the traffic, we need to make sure that it is not the designated router. So we're going to be doing this testing from router 8, from router 10 as well. So on router 8, if we look at the show run on its interface, which here is show run interface fast Ethernet 00, I previously configured the PIM DR priority to be 0. Basically, this means that I'm not the designated router for the segment. So I'm not the one who's in charge of doing registrations. What I want to see happen is that when I send the actual data plane out, so this is going to be an ICMP ping that's going to some multicast destination, doesn't matter what it is. But when XR2 receives this, it says my interface is the designated router for that segment, so I should be sending the unicast register message to router 1 telling them about this new S, G pair. If router 1 installs the S, G and replies back with the register stop message, which is essentially the ACK or the acknowledgement, and then we know that the registration over the MDT tunnel is working. But in certain cases, if router 8 was the DR, it would not do a registration for its own locally generated traffic. So just make sure when you're doing this testing that wherever you're generating the packets from, the other end of the link is the DR. In a real design, you never run into this problem because the multicast traffic is not coming from the router itself. It's coming from some application server that's on the LAN segment. Like I mentioned before, like your IPTV server or some sort of media application. But here, since we're testing it from the command line itself, we need to make sure that the registration is going to work properly. So on router 8, let's do a ping. Let's say 228.88.88.88. So some new address. And we'll send a bunch of these packets. Extended commands. Yes, I want this to go out just fast Ethernet 0/0. And it's going to come from that address that's on the link, which is 10.8.20.8. Now, if this is working, what we should see is that if we go to router 1 and now look at the show IP mroute for 228.88.88.88, it should know about that S, G pair, which it does. So this means that the registration from XR2 was properly sent all the way across the MDT tunnel to get to the other customer site. Now at this point, the outgoing interface is null because there's no receivers that are listening for 228.88.88.88. But since we already know that the shared tree joins are working, the final step then would just be to have someone join this address. So if we were to go to router 10 and join 228.88.88.88, we should see that now the traffic is going to flow end to end. So IP IGMP join that address. If we look at the change on router 1, we should see the outgoing interface is updated back to the fast Ethernet. And ultimately, we should see that the packets are going through end to end, which they are. So now let's look at this verification from the service provider core's perspective. When this traffic is coming from the customer, what actually happens when the pings gets to XR1 and they're trying to get down to router 10? Because we know that these packets are not being label switched right now because they have multicast destinations. They should simply be encapsulated inside the multi-point GRE tunnel, which is the MDT, and then forward down to router 5. So from, again, the customer's point of view, on XR2, if we were to look at the show PIM topology, we should see the S, G, which is the 10.8, 20.8, 28.88.88.88. Okay, this one is currently forwarding. It says forwarding out POS 0700. Then if we were to look at that, those counters, the show MFib route rate or the route statistics, eventually we should see that this is going to update so that there are some packets being sent. We could see for these other ones, nothing is being sent like to these auto RP groups. If we were to say show MFib route statistics, this is going to show us the counters for those individual groups. But the key is that we should see that this is actually forwarding. So we do know about that S, G pair. Eventually, these counters would get updated. Now, if we go down to the other side, which is router 9. On router 9, we could verify this with the show IPM route count, because this is in its global routing table. It says that I know about the group 228.88.88.88. I know about this source. So these two together are making up the S, G pair. What I want to see also here is that the packets are being received and they're being forwarded. If they're being received but they're being dropped, it means that for some reason the tree is not properly built. So eventually, once they get to router 10, 10 is going to drop those because there's no one beyond it that it needs to forward to. But if we were to go to 10 and look at the debug IPM packet, we should see the final feed coming in because this is the last hop device. So we know that the feed is working from the customer side. And from the customer side, it's the native source and destination. So it does not know that it went inside a GRE encapsulation somewhere in the transit path. But if we were to look at the service provider core, let's say on router 6, 6 is not going to know about 228.88.88.88. The only thing that 6 should know is about the MDT tunnel that is allowing us to forward the traffic from XR1 to router 5. So if we were to look at the show IPM route on router 6, we're not going to see about that customer's group. So we do see the 3 S, G pairs for the MDT, but we don't see the final group address. If we were to look at the show IPM route count, we should see the one that has the counters going up on it is going to be the one that is coming from 19. That's the one that's ultimately forwarding down towards router 5. So let's say show IPM route count include 19.19. We'll see that this counter is going to keep going up. These are the pings that are going through the service provider core. If we were to then to look at a packet level debug, if we were to turn off fast switching for multicast and then look at like a debug IPM packet detail, we would see that this is going to be the GRE traffic that is between the customer sites. let's see, this command is no longer supported. Use debug IP mfib ps. And I want to say that I'm going to have to turn off fast switching to do this, but the problem is that's going to break the rest of the config. So I'm not going to show the debug for this. You can do this on your own. Just the final result is that it's going to show you that it's a GRE packet that is being sent across the network. But the key is that from the core's perspective, essentially the customer's traffic is hidden from them because they don't know about the customer sources. They don't know about the customer destinations. As long as we can build the MDT tunnel, the same type of logic as the MPLS tunnel, except we're just using GRE. We're not using the label switching.